Okay, what we have to cover here is the last main topic that will appear on the AP test, and that's inference about the least squared regression line. Now, what I want to do is go through a couple examples. At the end, we'll have some time for you to go back and copy down the main slides. We're also going to practice 2 AP questions. We're going to do 1 example during class, and then again the 2 AP questions. Here's what I want you to understand. This right here, this inference about the least squared regression line, is going to take one regression line and compare it against all possible regression lines. And in addition, we'll talk about how we can calculate a confidence interval that will help us see. We're going to conduct a confidence interval about a slope, about how accurate is our slope. So that's where we're going to start. Now, first thing here, we're going to start as a review about how to calculate a least squared regression line. This is some data that's in the book dealing with some type of prehistoric beast, and we're comparing the length of a femur versus the humerus, with the femur being along here, along the x-axis, and the humerus being along the y-axis. Now, the calculator did that. However, I blocked out the equation because I want to talk about what information we need, again, to generate the least squared regression line. Some of the key facts, again, for review. In statistics, we write it as a plus bx. A is our y-intercept, b is our slope, r is our correlation coefficient, always a value between -1 and 1. The closer it is to either -1 or 1, the stronger the fit to the line. R squared is our variance. Again, variance is the percent variation of y that can be explained by x. In this case here, the percent of variation of humerus length that can be explained by the femur length. Some other information we pulled out here. You can see I pulled this out of 2 variable statistics, and you want to, again, L1 and L2. Here's the key information we need right now to calculate. Let's start with the slope. We're going to need to have R. We're going to need to have SY. Again, the standard deviation of y, and also the standard deviation of x. Now, we're going to need those for calculating the slope. Quick review. Slope, again, is R SY over SX. So we have these 3 pieces of information. And again, copy these down, please. R equals 0.994. SY equals 15.89, SX equals 198, just to make it easy. And to do that, we're going to do correlation coefficient times SY over SX. Don't forget, again, slope is y over x, so it's still y over x times r. This is on the front page of your AP packet. This, again, is on the front page, second equation up. So, let's go ahead and determine the equation of the least squared regression line. In this case here, R is 0.994, 13.198, 15.89. B equals 0.994. Again, SY, 15.89, and SX, 13.198, and when you calculate that, you will come up with approximately 1.197. Now, to figure out the A term, again, this is going to be written as y equals a plus bx. The A term is y bar minus bx bar. Y bar is 66, x bar is 58.2. Again, y bar 66 minus b 58.2. And again, here's B. So we can generate that equation as 66 minus 1.197 and 58.2. and we come up with y hat, correction, we come up with a being negative 3.66. So our final equation, y hat, is negative 3.66 plus 1.197x. Or, another way to look at it, in this case here, because again this was femur and humerus, we can write humerus equals negative 3.66 plus 1.197 femur. We'll go through how the AP test gives you the same data and can go through how the AP test gives you this data in different table formats, and you can generate this. But what I want you to try right now is this. I want you to enter this data into L1 and L2. I want you to create a scatter plot. I want you to calculate the least squared regression line, record correlation and variance, and also determine the residual plot. So go ahead and calculate, create this data. And just to let you know, this data can also be found in your book. This data can be found in your book on page... This data can be found in your book, and I'm looking for the page, and it is found on page 786. So, take about 3 minutes here, enter the data into the calculator, again, create a scatter plot, create a residual plot. Again, you can get that under second stat plot, and you will do your data. Don't forget, you can pull up residual by going under second list, and you can pull it up that way. So we're going to take a couple moments here, maybe on 3 to 4 minutes, enter this data in, and we'll talk about what we're going to do from there next.